Hello everyone and welcome to the channel. In this video, we're going to use Python for time series forecasting. We will try to predict the daily gold price based on the historical data for the past 10 years. We will try different models, we will try statistical models, and we will try machine learning models, and at the end of the video, we will discuss the differences. So let's start. So first, let's start with the machine learning algorithm. So we will be using XGBoost, which stands for Extreme Gradient Boosting, which is a type of ensemble learning, which is basically builds an ensemble of decision trees, and each tree corrects the error of the previous one. We will need also pandas to work with data frames. We will need matplots to plot the results, and from sklearn we need the error metrics. So let's run this. These are the libraries that we need. And now let's load our data, which is the gold stock price. I will leave the link for the data in the description of this video. So let's load our data. As you can see, we have the date. And if we want to see, so we have 2,511 rows, which is almost the data from 2014 to 2024. So we have the date, we have the opening price in that specific day, we have the closing price, the volume of gold, and what was the highest price in that day, what was the lowest price in that day. So to make it simple, in this example, we will just need the date and what was the highest price in that specific date, and we will try to predict that. So we need to copy to extract only the date and the high price in a new data frame, and to make the date as our index. So let's do this here. We will copy into the data, a new data frame, the date and what was the highest price, and we want to make sure that the date is following the pandas standard date time, and then we will set the date as the index, and we will rename the column high into gold stock price. So let's run this, and as you can see, we have the date as the index, and we have the column of the highest price has been renamed into gold stock price. Now let's visualize our data. So this is our data from 2014 to 2024. This is the price, the gold stock price. Okay. So now let's split our data into a training and a test. We will be taking the data after the 1st of January 2022 as the test data, and then before that will be the training data. So we have split it. Let's visualize our data now. So this is going to be our training set in orange from 2014 to 2022, and the last 2 years will be our testing test set. Okay. Now let's define this function to extract the features of the time series. So from each date, what was the day of the week, what was the day of the year, what was the day of the month, and so on. So these features are important for better training. And yeah, so now as you can see, we defined this function and we extracted the features of the X training, Y training, and the X test and Y test. If you want to see this, we can say here X training, X train, and as you can see, for each date we have features have been extracted from the date. What is the day of the month, what is the day of the year, and so on. And what is the Y train? Y train is, as you can see here, we don't have the price, we have only the date and the features extracted from the date, and the Y train is the date associated with the price. So similarly for the test data set, so we will be passing to the model the features as X, the date and the features as X and the date and the price as Y. And similarly is for the X test and Y test. Now let's train our model. We will call the model and we will pass only one parameter, which is the number of trees. There is a lot of parameters you can play with if you want to improve the performance. I will also leave the link for the documentation for this model. If you want to improve the performance, you can try to play with the parameters. For now, we will only keep everything as default. We will only use the n estimators, which is the number of trees. And then we will pass the XY train, and then the X test and Y test. Okay, so now we have trained our model. Let's plot the importance. If you remember from these features, we want to see which features were the most important during the training. So if we plot this function, we just imported it here. Yeah, here. So plot importance. So we go back. So we plot the importance after training. If you can see, the day of the year was the most important feature. So this number is how many times this feature was mentioned in the trees. So based on that, it will give you an idea of the importance of the different features in your data. Okay. Now let's do the prediction. Since we have already the training, the model has been already trained. Let's pass the test data set without giving the y, because we know what is the y, but we will try to predict and we will compare. So we'll pass the x and we will add it as a new column to the test data frame, and then we will combine the test and train in one data frame. So let's run this, and now if you can see, we have the price, we have the features, and we have the predicted price, the new column that we have added. The date is here as in two columns because we have the date in the X and in the Y, so it's okay. But now we have one data frame that has the predictions. And now finally, let's plot this and then calculate the error metrics. So from this new data frame, the predictions, we want to plot the gold price and the predicted price. So let's plot this. And now we can see this is the original data and this is the predictions in orange. It's not too bad, and we can now go and calculate the error metrics to see how good is this prediction. So let's calculate. This is also was imported from the sklearn library, so you don't need to worry about it. You just need to pass the y true and the y predicted. So we are passing the test data frame, and then with the gold with the predictions and the original price. So this is the predictions, this is the original price. So we are calculating three error metrics: RMSE, root mean square error, the MAE, which is the mean absolute error, and the mean absolute percentage error. Let's run this. And as you can see, this is the RMSE, this is the MAE, and the mean absolute percentage error is 6%, 6.4%. Okay. Now let's try a statistical method for forecasting. We will be using HoltWinters from StatsForecast. This is also known as the triple exponential smoothing, which captures both trend and seasonality. So we need also pandas. We will need HoltWinters from StatsForecast, and we need from sklearn the error metrics. Similarly, as we did in the previous one, we will load the data. We need only the date and the high price column. And in this one, we need to add a new column and we name it as a unique ID. So this algorithm assumes that there is a column named as unique ID in your data. If you don't have this one, it will give you an error. So we are adding a new column to our data frame, and we will just name it as unique ID as required by the library, and we will just pass a gold stock text into that column. And also the date, we make sure that it follows the standard format by pandas. And then also the date has to be renamed into DS. This is required by the library, and also the price or the column that you are trying to predict must be renamed into Y. So the library requirement is that it will look for these columns. If you don't have them in your data, it will give you an error. So let's run this. Now we have the date as DS, we have the high price as Y, and we have the new column named unique ID, and we're just giving it a name as a gold stock. Now, let's build the model. So we're selecting the model and we're giving a season length of 1 year, and the frequency of our data is a daily data. And let's fit our data and create a forecast. So this model is basically to create a future forecast. So it will give you also a forecast for 1 year ahead. But in our case, we want to access the fitted data. We are not interested in the future rather than the fitted data to evaluate the performance of the model. So if you want to access the fitted data, we have to give also to pass this parameter fitted as true, and then we will access the fitted data through this this line. So fitted data into this data frame from the forecast data frame. So if we run this, we are expecting now to have two data frames. One is for the forecast, including the future data, and one data frame is for the fitted data. Okay, now the model training has been finished. Let's now see the two data frames. So forecast data frame, if you can see, we have the predictions for 1 year, which is the future starting from the 20th of January 2024, which is, if you remember that our data is the last day in our data is the 19th of January 2024. So this is 1 year future forecast. We are not interested in this one rather than to evaluate the performance of the model. So let's see the fitted data. So this data frame, if you can see now, we have from 2014 until the 19th of January of 2024. This is the Y, and this is the fitted data, the predictions for our data, not for the future. So we will be using this one to evaluate the model. So now we are setting the date as the index column, and we are plotting the predictions HoltWinters against Y in the fitted data frame, in the fitted values data frame. So this is our gold price against, which is Y, against the predictions by the HoltWinters algorithm, as we said, which is a statistical method based on the exponential smoothing. So this is the predictions. It looks quite good. And now let's see how to calculate the error metrics. So to make a fair comparison with the previous method we discussed, which was the machine learning XGBoost, if you remember, we only evaluated the model or the error metrics based on the last 2 years, from 2022 to 2024. So we'll do the same. So from this data frame, we want to take only the data after the 1st of January of 2022, and then we will evaluate the errors metrics for only these 2 years. So let's run this, and if we can see now the RMSE and the mean absolute error and mean absolute percentage error is 4%, which is better than the previous method, which is the machine learning using XGBoost, which is, as we said, is based on decision trees. The last model we will discuss in this video is Facebook Prophet, which is a model developed by Facebook data science team. This model is an additive model, which is more of a statistical model than a machine learning model. So also we need pandas, we need to import Prophet, and then we import a matplot. So similarly as we did, so let's run this. Similarly as we did in the previous models, we load our data. We copy only the 2 columns that we want, the date and the high price. And then we will make sure that the date is following the pandas standard format. And we will rename the date column into DS and the high price column into Y. This is also a requirement by the library. If you don't have these columns, it will give you an error. We run this. Now we have, this is our data frame. DS is the date, Y is the price that we are trying to predict. It's very simple to use this model. You just have to call the model, and you set the seasonality to true, and you fit the data, and then you start to predict. So also this model is for predicting future forecast. So in this case also it will give us some predictions for 1 year ahead. And then the frequency for our data is a daily data, and then we will do the prediction. And it will return for us the data frame for the predictions. So if we run this, we can see now it will return also a lot of features. We can see here is the date. It is starting from the 2014, and it is giving us up to 2025, which is 1 year more predictions. If we go here, the last column is the predictions, the y hat. Okay. As we said, we are not interested in doing future predictions rather than to evaluate the performance of the model in predicting our data, the fitted data. So let's plot the performance of this model. We can see here the blue line is the predictions. It looks very good. And we have also 1 more year of future predictions. And also we have a confidence interval of 90%, is the default. We did not, there is a lot of parameters that you can play with here for the model. We did not change any of the parameters, but again, I will leave the documentation for this model in the description of this video. If you want to use this model and then you improve its performance, you can play with the parameters until you get a good results. So this is fitted data and the future forecast. And now let's see how to get the error metrics. This model has its own built-in functions for the error metrics. So from Prophet, we have to call or to import from the Prophet diagnostics, we import the cross validation. And the cross validation, you have to pass the training data. We are passing like 2000 point of data as a training, initial training, and then it will forecast 1 year after that, after the training. And then the performance metrics, it will give you all the error metrics in the data frame performance. If you run this, it will now give you the data frame for the error metrics. Here, as you can see, all the error metrics that you need. You can simply also call import the plot cross validation metric, and you plot this data frame, and it will give you the performance of the mean absolute percentage error. As you can see, it started around 6%, and then it was increasing, and at the end it was around 15. You can improve this by changing the parameters of the model, or also here for the cross validation, because we are predicting for 1 year at one time. If you predict 1 month at a time, you will get much more improved performance. So that is it. We did in this video 3 models. We did the machine learning XGBoost. We did the exponential smoothing, or the triple exponential smoothing, known as the HoltWinters, and we did also Facebook profit. The takeaway of this video is that we cannot say that machine learning is always the best for time series forecasting, and also we cannot say that statistical methods are also the best always. It depends on your data, your application. All what you need to do is to try several methods, several algorithms, and then you choose the best that suits your data and your application. Sometimes simple statistical method can still beat machine learning, sophisticated machine learning algorithms, depending on the data you are working on. Okay, and thank you if you reach up to this point of the video.